All right, so we're going to be learning how to multiply polynomials. This is 5.3 multiplied polynomials. All right, so the first type that we're gonna do is we're gonna be multiplying monomials. Okay, and we could use the commutative and the associative properties for the terms and laws of exponents to work with the variables. Okay, so use the commutative and associative properties for the terms and laws of exponents to work with the variables. Okay, so then the first one says we have negative 3x to the 5th times y to the 6th z. We're going to multiply by negative 2, 9x y to the 8th z to the 4th. All right, so what I will do first, I know my answer is going to be positive because both terms are negative. Now I have 3 times 2 is 6 divided by 9. I'll simplify later, okay? X to the 5th and to the 1. If I add them, will be to the 6th. Y, 6 plus 8 is 14. And Z, 1 plus 4 is 5. All right, so all I need to do is simplify. Divided by 3 is 2. Divided by 3 is 3. So my answer is going to be 2/3 of x to the 6, y to the 14, and z to the 5. That's what I need to do when it's multiplying monomials. Now multiplying monomial and a polynomial. Oops, did I move the camera? Hold on. No. So multiplying monomial and a polynomial. So we use the distributive property, and we cannot forget to follow the order of operations. So we're gonna use the distributive property and do not forget to follow order of operations. So let me do one of these ones. 2x to the 3rd times 5x to the 4th minus 2x to the 3rd plus x minus 8. All right, so I'm gonna distribute. So this one, this term times this one is 2 times 5 is 10. X to the 3rd times x to the 4th is x to the 7. 2 times 2 Negative 2 is 4. 3 plus 3 is 6. This is 2x. 3 plus 1 is 4. 2 times negative 8 is negative 16x to the third power. And I just multiply by by a monomial by a polynomial. Now let's multiply a binomial by a binomial. And we are not going to do what you guys learned in high school, FOIL. We're not going to be doing that. We are always going to be using, we're always going to be doing the distributive property. Okay? So this one is, we're going to be multiplying a binomial times another binomial. Okay? So this is what we get. Let me do this one. 2x minus 7 times 3x plus 5. Okay, so then I multiply this one times this term. 2x times 3x is 6x squared. 2x times 5 is 10x. Now, negative 7 times 3 is negative 21x. Negative 7 times 5 is negative 35. Now I'm going to combine the like terms. In this case, it's these two terms, 6x squared minus what? Minus 11x minus 35. And this should be my answer. Now, if I have to multiply, they're giving me 5n plus 2 squared. We know that this is equal to 5n plus 2 squared, times 5n plus 2. Okay, so then what do I do first? Multiply this 5n times 5n. So it would be 25n squared. Now, 5 times 2 is 10n. Then 2 times 5n is another 10n. And 2 times 2 is 4. So what is going to happen here? I'm going to combine the like terms. This is going to be 25n squared plus 20n plus 4. And that's going to be my answer. Now, let's do, we multiply monomials, we multiply monomial by a polynomial, we multiply a binomial by a binomial, and now certain binomials pairs are special and can be multiplied with very little effort if we recognize them. Okay? And it was just the last one that I did. So let me write that down. Certain binomial pairs are special. Okay? And with very little effort. If you recognize them, okay? So then let me show you. What was number 7? Oh, the one that I just did. This one, 5n plus 2 squared. This is what we call a square of a binomial. And this one, so that means that a plus b squared is equal to a squared plus 2 times ab plus b squared. And if I have a negative, the only difference is that this second term is going to be negative. So what happened here? I could have done this one, it's the same as this one. So this one was what? A is 5n squared, which is 25n squared. The middle term is 2 times ab. So it's 5 times 2 is 10 plus times 2 is 20. So it would have been 20n plus the last one squared. 2 times 2 is 4. And this is exactly what we got on this one. If you guys can see, this is what we got. But we did the whole distribution. We multiplied and we distributed the numbers. But we could have applied one of these rules. Now, we need to note here that, let me write this down that way, that if we have a plus b squared, and this is the same as a squared plus 2ab plus b squared, this is not equal to a squared but plus b squared. Okay? Also, if we have a minus b squared, it's the same as what we just did it. And this is not a squared minus b squared. Don't forget that. Okay? No, it needs to be a plus b, everything to the second power. Now, the other exercise was, we didn't do it, but this one is the difference, the product of the sum of difference of two terms. Product of the sum and difference of two terms. And it's a plus b, a minus b. The product of the sum and difference of two terms, which is equal to a squared minus b squared. So the example that we had was this one. So what do? The first one is square. 3 times 3 is 9 squared. And b, 8 times 8, 64. All right? I could have done it, and you see it if we just recognize it right away. Otherwise, okay, we just three times 3 is 9m squared and 24m. Negative 8 plus times 3 is negative 24m. And 8 times 8 is 64, and it's going to be negative. So what happened here? Like terms, this becomes 0. And what do I have left? M squared, 9m squared minus 64, which is exactly what we just got here. Exactly the same. If I just remember this. Now, when we're doing multiplication, all you need to take into consideration or always remember is that you are going to you're always going to be will do a distribution. Okay, you will do a distribution no matter what type of polynomial we have. I'm going to write it down up here. So right here we will do a distribution no matter what type of polynomial we have. Don't forget that, okay? No matter what type, we're always going to be doing distribution. Distribution, okay? We're going to distribute. And it's going to be plenty of exercises that you're going to find in your so we multiply monomial by a monomial. We just did that. You just do distribution. We did the monomial by a polynomial, binomial by binomial. Then we did that certain binomials per special. And if we remember, we will be saving some time. If not, that's okay. You can still do it the way we've been doing it. Let me do this. Let me do a couple more. This one is those are more exercises. I'm doing monomials. So for example, 3/5 times 8⁵ minus this is multiplied. I encourage you to take a look at the book too. You can download it. I have it as one of the tabs in Blackboard, your Blackboard course, where it says textbooks. You can download it, and there are more exercises there too. Okay, so all of this is multiplication. So we have 3. We could do the 15 here. 8⁵. What do we get? 5 plus -5, 8 to the 0 power, right? This is -3 plus 1, -2. 1 plus 4, -3. So then what is going to happen? First, let me simplify it. Divided by 5, 1. Divided by 5, 3. So I'm going to have a 9. What did we say this one was? This is a 1. What's the reciprocal? It's going to be 1/d to the 3rd power. So my answer is going to be 9 over c to the second power times d, okay? Now let's do one more monomial by a polynomial. 2n squared times 5n cubed minus 3 plus 8. Right here, what I'm going to do is I'm going to take care of the parentheses first, meaning this is 5n to the this is going to be negative, and this is going to be negative because we have a negative in front of the parentheses. Now let's do the distribution. So what do we have there? We have 2 times 5 is 10. 2 plus 3 is 5. 2 times 3 is 6. 2 plus 1 is 3. 8 times 2 is negative 16. And this is my answer there. Okay? And let's see, did we do this one? No. Oh, I still gotta go on. Hold on. Number 4, we're going to multiply. This is called multiplying other polynomials. So it says to use the distributive property as many times as needed. So we're going to use the distributive property as many times as needed. Okay? We're going to combine like terms. I do prefer do the vertical, do it in vertical. To say I would like to do it because I save a space and I line up the like terms as I go. So I'll write it down. You don't have to. So you're going to line up terms. Line up terms. I'll show you what I mean. That was in the mainly in the addition and subtraction, but here we might have to do that too. We have 5x minus 3 multiplied by what? 3x squared minus 5x plus 7. So first one is this one times this one. So we have 5x times 3 is going to be 15x to the third power. This is going to be negative 25x squared. And this is going to be 35 plus 35x. Now, let's do the other one. This is going to be what? 3 times 3, 9, but it's going to be negative. You see? I'm going to line up the terms. So 9x to the what? To the second power. So it's supposed to be going here. Now, this one times this one, it would be plus 15x. And this one is going to be minus 21. So this one, what do we do here? 24 plus 9, I believe is 34. And this would be 10, 4, 5. And this is my answer. So what I was saying was that I prefer to do this terms as I go, just like I did it now. And we could multiply 3 look at this one. This one is multiplying 3 or more polynomials. We could do another one of these ones. This one would be 2n minus 4n to the third power plus 5 multiplied by 2n plus 6n squared plus 3. So let's do it. Don't forget that if we apply the negative sign here, this is going to be negative, and this is going to be negative. So 2n times 2n will be 4n squared. Nothing happens because it has a plus. This will be 12n to the third power. And the last one is going to be 6n. Now, let's do this one. We have, it's going to be negative. That's going to be negative 8n to the what? To the fourth power, which we don't have any. We could write it down here. Negative 8n to the fourth power. Now this one is going to be negative 24n to the fifth power. And the last one is going to be negative 4 times 3 is 12n to the third power. Now, let me get a different color, Marino. This one. Now the 5 is going to be negative 5 times 2. So it's going to be negative 10n. Negative 5 times 6 n squared is going to be negative 30n squared. And negative 5 times 3 is going to be negative 15. So we're going to have, we're going to do it in order, negative 24n to the fifth minus 8n to the fourth. Then we could add this 2. It's going to be negative 26n to the second. This is, we make a 0. Minus what? Minus 4n minus 15. That will be our answer. I don't know if we're really going to see examples like this. The other one that I have is multiplying 3 or more polynomials. I don't remember seeing them, but this one is multiplying 3 or more. 3 or more polynomials. So we use the what? The associative and the commutative properties. Let me just give you an example here. What did we say y plus when we have one positive and one negative. The product of the sum and the difference of what? Of two terms was what? A squared minus B squared. Okay, so we could get that from these two. A multiply this by this one. Okay, so what we have here is this. This is what we have here. And this is the same as this one. This is like we have A minus B squared equals to A squared minus 2AB plus B squared. Let's do it that way. So it's going to be y to the fourth minus 2 times A and B. That would be 8. Y to the second. And the last one will be 4 times 4 will be 16. This will be my answer. Or let's try it. Y to the second minus 4 times y to the second minus 4. So we do y to the fourth negative 4y negative 4y squared and plus 16. So we combine the like terms and we get 8y squared plus 16. You see, we got exactly the same answer. Doesn't matter how we do it. If we don't remember this, that is the product of the sum and the difference of two terms, that's okay.